Okay, so you can quickly establish an SD-WAN overlay fabric to the connect data center branches. Already have discussed, and SD-WAN decouples the forwarding plane from the control and management plane. So you understand that, right? So now they all are not in the same chassis, not in the same physical enclosure. So you can understand like this, like here if there is a data forwarding plane and controllers here. So here like there is a transport here, internet or MPLS or any other transport, just to provide IP reachability, because wireless devices, the forwarding plane should be able to reach out to the controller. So for that, like there is some like transport here, like maybe internet here. Earlier in the past, like in Cisco 65 or 4500 or some other like modular switches, like all different planes, like in the same chassis, in the same physical enclosure, like connected of course with the some backplane. But here like the transport is different here, and even if like the transport is internet, so there's no point to worry. Why? Because like there is secure data and secure control plane exchange, right? So basically OMP runs inside GTLS tunnel. So control plane exchange is very secure. What about data plane? Again secure. IPsec tunnel is there, so need not to worry about like this, right? Okay, advantages. So first, transport independence, right? Reducing cost with transport independence. So as I mentioned earlier, SD-WAN is transport independence. There has to be a reachability, of course, but what transport we have used there in underlay network is not important really, because this SD-WAN is complete overlay solution, overlay. So there has to be a reachability, but what transport is there? SD-WAN, like there's no like additional configuration required for that. A single centralized cloud delivered management dashboard. So even your controllers can be in cloud also, right? On-prem data center or cloud based. And most of the enterprises, they prefer cloud hosted controllers rather than on-prem data center or like in your local IT infrastructure, right? But of course, if you want, then you can have like controllers in your own data center, no problem whatsoever. If you don't want, then yes, they can be in the cloud, no worries. The single centralized cloud delivered management dashboard for configuration, management of WAN, cloud, and security. Security, I will talk about the security part also, that is also important. Template based zero touch provisioning for all location, branch, campus, and cloud. So yes, in case like if the device is like ZTP or PNP, so as I said earlier, no configuration is required at all, right? And how it is done automatically, I will explain later on when I will talk about like initializing WAN edge devices, right? Because in case like if the device is ZTP or PNP, then PNP is basically a Cisco term, ZTP like VIPTELA. So I'll explain that like how what like configuration that device would have already there, and then how device will contact the controllers, right? Of course, after obtaining IP configuration, I mean like the IP gateway and mask and all that. But even in case if there is no GTP or PNP, right? So very minimum configuration would be required there. Very minimum configuration would be required, and what configuration I will explain that. So, and that is why there is seamless extension of WAN. And not only WAN, even we can extend our SD-WAN fabric in very seamless manner to cloud even, right? Cloud, because like here in SD-WAN, there are different options like cloud and RAM. So this SD-WAN fabric can be extended in very seamless manner to the cloud. That part I will explain later on, right? So don't get confused with that part. Okay, so I hope you understood all the points. Reducing cost over transport independence, understood. a single centralized, not necessarily cloud-based, because management server or controllers can be in the data center, on-prem data center. So not necessarily has to be a cloud delivered, but yes, centralized management dashboard for configuration and management of WAN, cloud, and security. Template based, zero touch provisioning. Template based means like if I mean like let's say uh, there are 2, 3, or 4 WAN edge devices. You want to configure them, right? And very identical or similar configuration are required on all 4 WAN edge devices. So what we do, we create a template, right? And in template, we configure everything, right? Some global parameters, global, I mean like the same values, and some variables, right? And then we attach WAN edge devices with the template. I mean like we push configuration to directly to the WAN edge devices. Variables will be asked at that point, in fact, when we push the configuration. And global, of course, the name itself suggests global means like same. Let's say you want to enable OSPF on all WAN edge router. You want to use the same process ID number. Interfaces like same interface connected to the LAN segment and should be in the area 0. You want to advertise a default route there. So what we'll do, we will just configure those parameters as global. But what about the router ID? You should be unique, of course, right? So that is what variable is. So basically in template, when we create template, then there are different options there. But templates are used for what? To configure WAN edge devices. WAN edge devices, right? WAN edge devices are configured with the help of template. And there is another term, policy, is different than the template, right? Forward purpose policies are used in SD-WAN to manipulate path selection, to configure application aware routing, QoS configuration, quality of service, right? Or even changing topology from full mesh to hub and spoke topology. For all this, what we do, we configure policy templates for the device configuration, not for the policy purpose, right? Not for the policy purpose. And in policy also, like we have two different options. If we want to push policy directly to the WAN edge device, that can be done also. But most of the time we create central policy, centralized policy. Centralized means we create policy from the vManage, then we push it to the vSmart, and then depending like what kind of policy, forward purpose, like whether to affect data traffic or control traffic, for what purpose we have created the policy. Accordingly, either policy will remain to the vSmart only, or maybe vSmart will further push it down to the WAN edge devices, right? But centralized policy means policy is activated to the vSmart, not to the WAN edge devices. So don't get confused with that, and we'll look at both like policy and template, but template and policy, and they both are really very, very important in coming section, right? Policy and template. Most of the time, we will be playing with both template and policy. And don't get confused, right? Template means configuring WAN edge devices, correct? Policy, the name itself suggests policy, means like configuring application aware routing, setting up preference value, changing topology, QoS policy, right? Route filtering. So it's what? Policy. Okay. And seamless extension of WAN, already I have explained this point. All right. Next, detailed reporting of application and WAN performance for business analytics and bandwidth forecasting. So very detailed reporting is there in the vManage, right? Related to and of course there is a proper application visibility. More than 1,000 applications are listed there. Even we can create policy based on applications or service ports even, right? And I hope you understand like the difference between both services and applications, because in SD-WAN we when we create application aware routing, and you understand application, what does application aware routing means like selecting path or transport based on applications, right? So that's what application aware routing means. In traditional networking, in order to like do this like application aware routing, the only option is what? Creating ACL, matching with the ACL, then further creating route map, and then with the route map we can do some kind of service based routing, right? But mainly on the basis of destination ports, because in ACL like what we match IPs and ports only, right? Most of the time, I mean like what when we create route map, then we match with the ACL, and in ACL we match with either the IPs or ports. So in order to configure application aware routing in traditional routers, the only option was creating route map. So very limited option based on service ports only. And even if you have 100 or 200 routers or WAN edge devices, so really it's very difficult. Like no like centralized management and configuration sort of thing. You need to assess it to all devices and then doing configuration. Here in SD-WAN, like this can be easily done, and not only on the basis of destination ports, even we have option to specify applications like the WhatsApp, MSN, Yahoo, and all that common or most well-known applications are listed there. So even we can configure application aware routing based on the services, and services means like destination port, looking at destination port only to identify applications, and application means what? Looking at layer 7 data, application header to identify the application, N bar, network based application recognition sort of thing, right? So here in SD-WAN there are more than 1,000 applications, so you can use them in application aware routing. But of course we cannot do like custom addition of applications for now. I mean like if you want to create app ID signature for your homegrown applications, custom applications, so not possible of course. So you cannot do that, but at least like common most applications are already there, so you can use them, and I will show you in the application aware routing section how to do that, how to create application aware routing. And I will show you both the options. First, like I will create application aware routing to match the destination port. I mean like to identify application, a destination port address should be taken into account, and then we will create, or I will show you another application aware routing policy based on application instead of destination port address, right? So yes, very easily we can configure application aware routing in SD-WAN. Secure data and control plane operation. Already I have explained this point. Why secure data plane? Because there is IPsec tunnel, and inside IPsec tunnel BFD is enabled. So data plane exchange of course is very secure. Why control plane exchange is secure? Because control plane protocol, that is OMP. I haven't talked about OMP up until, right? I will talk about this OMP later on. But this OMP is the control plane protocol, right? It is enabled by default, and it runs between VS device, WAN edge device, and vSmart, like the control plane, not between the VSs. No. So if we want to see the OMP peering, so OMP peering or neighborship will be between VS and the vSmart, right? So this OMP, this control plane protocol, is enabled by default, and it runs inside the secure channel, that is DTLS or TLS tunnel. Simplicity, at enterprise scale, which enables end-to-end policy from the user to the application over thousands of sites. So even if you have 1,000 sites, you want to create policy and same policy for all 1,000 sites, very easily you can do that, right? From the centralized management server. Create the policy. Once it is done, then push it either to the vSmart in case of centralized policy and localized policy, then directly to the WAN edge devices or maybe group of WAN edge devices. You can push it down to all WAN edge devices, to all the sites. We can create policy based on VPNs even. And as I said earlier, as I mentioned, VPN here means what? IPsec VPN? No. This VPN here is similar to VRF, network segmentation, right? And by default, different VPNs do not communicate with each other by default. But what if you want that? You want route leaking sort of thing? You want that VPN 10 users should communicate to VPN 20 users? Will that be possible? Yes, of course, right? Very similar to what you do in like your VRF concept, VRF export and import policy. Same here, like we need to create a policy. We need to import prefixes from one VPN to another VPN. So yes, with that, yes, inter VPN, different VPNs, they all communicate with each other, right? And uh, uh, we will see all this like in lab also, how to do all this. Okay. So the next point here is faster cloud access by enabling direct internet access at the branch. So in past, branches, they first connect to the headquarter or the data center, right? With any link or MPLS or any lease circuit. So branch office to the headquarter and then from the headquarter to the internet site. Or security devices, appliances here at the headquarter site. So branches, they first route packet to the headquarter data center and then to the internet. It means like first backhaul to this headquarter and then to the internet. But here in SD-WAN, there is a solution of like a direct internet access, a local breakout. It means branches can securely and intelligently connect to the internet directly, right? And even in case if there are two different ISPs here, so we can bring here like performance based routing or application aware routing into picture, right? We will create service level agreement that prefer ISP one link as long there is minimum delay, loss and jitter. And if like packet loss or delay is more than that what we have specified in the service level agreement, then fail over to ISP2. Even if both they are not meeting up like service level agreement parameters, then first route packet to headquarter and then route to the internet. Maybe like here, like in there's some issue in the local loop service provider network, right? It is possible. And even we can integrate some cloud security here, maybe like Cisco umbrella to provide the security. And even some WAN edge devices, they have built-in zone-based firewall, application-based firewall built in there, not very sophisticated. So branch is routers, of course. For that, yes, no need to put a dedicated firewall there. But for larger sites, headquarters or data centers, of course, like you need to put a dedicated firewall there because built-in security is of course not for very large site, in fact large number of users, not sophisticated, but yes, zone based and other firewall solution is there. Or of course alternatively you can integrate this cloud security with that. I mean like Cisco umbrella, Zscaler sort of thing, if you are aware with that. I'll discuss that also. So at least in SD-WAN solution, there is a direct internet access, a local breakout, right? What we will do, we'll configure NAT and with some policy, a specific branch site traffic will be routed directly to the internet rather than just like routing first to the headquarter or data center and then to the internet. So for that, what we need to do, we simply need to create we have to enable NAT and then a very basic policy, in fact, right? From this to this, no NAT, and from here to here, NAT kind of thing. I will show you that also. Okay, so delivering fast cloud access by enabling direct internet access at the branch, right? And if you look at this diagram here, so any service, like of course transport independent, any service and any transport independent, so can be internet, MPLS, 5G, satellite, and any location, be that the branch, co-location, cloud, data center, or headquarter. And deployment wise, yes, your controllers can be like on-prem, cloud, or multi-tenancy or multi-tenant, right? MSPs something. So uh, any deployment, any service, and any transport, any location. And very quickly, I'm going to show you the dashboard of management server also.